Good afternoon. Welcome to the explanation for 6G Part 2, which is interpreting the graphs of linear models in their context. All right, when we talk about context, we're talking about the circumstances surrounding the graph. So it's talking about the actual raw numbers that are being used and the variables that are being determined. It's not just X and Y. All right, it is about using the variables that we are given and the information that we are given to therefore make an equation up. So looking at this graph that I've got here, a phone company charges a monthly service fee plus the cost of calls. The graph opposite gives the total monthly charge for making n number of calls. This includes the service fee. So think of the monthly service fee as the constant that you are always paying. All right, the constant in this case is also going to be our intercept on the y-axis. And if we look on the picture there, where is our y-axis? All right, and it is just there where the cost is equal to 10. So that means to start things off, our cost is automatically going to be $10. So no matter how much we use our phone, we are always paying $10. So let's put a note in here. Seem to have blown it up a little bit too big. Get down to something manageable. All right. So how much is the monthly service fee? $10. How much does the company charge if you are making 100 calls a month? So what we need to do is we need to go along our picture here. We need to find where n is 100. And then we need to go up the line and where the lines meet. So where my going up from 100 meets the red line, and it meets approximately, if I then go across, it meets halfway between 15 and 20. So what is halfway between 15 and 20? Halfway between 15 and 20, ladies and gentlemen. 17.5. So that's 17.5. But now we have to make sure that we interpret that in regards to the question. All right. 17.5 what? All right. $17. All right. So someone in there has suggested 17.50. Remember that because we are dealing with actual money, we need to make sure that we are keeping the dollars and cents consistent. We leave that zero on there. All right. So the next one is find the equation of the line in terms of C and N. So it wants you to create an equation. C equals something plus something N. All right. So what we have is we actually already know one of our values. So I'm going to bring up the whiteboard. And we will move over to the whiteboard to help us continue this question. So our whiteboard will help us with this, and you will probably need to make it a little bit bigger. So find the equation in terms of C and N. So we happen to know two pieces of information about our graph already. We happen to know two exact coordinates. All right, we know there, and because we've already worked it out, we know where that is. From that, we should be able to create ourselves an equation. All right, so what if I were to write these out as coordinates, what would those coordinates look like? What are those coordinates going to look like? Yep, I've got one there. Yep, that's good. Yep, 0, 10. And 117.5. Beautiful. All right. So, what are we going to do from here? All right. Because we're talking about linear models, I think it's fair enough if you guys want to break out the CAS for this question. All right. All right, we know how we've got our CAS, we have access to our CAS for our assessment tasks, so it's absolutely fair enough for us to break out the CAS for this question. So I'm going to break out mine. All right, there it is. For now. And so what we have here, main. So in here, we're going to go to statistics. All right, because we're doing this as a linear model thing, we're going to use the statistics function and we're going to use the linear regression function like we did last time. So conveniently, 0, 10 is already in my CAS for some reason from my last time I used it. And I'm going to change the other one to 117.5. I'm going to calc, regression, linear regression. I'm going to copy the formula into Y1 because why not? And then I'm going to hit OK. My calculator is set up so that it is in Y equals A plus BX, which is what we need. Y equals A plus BX. R equals 1, R squared equals 1, so it's a perfect fit because there's only 2 points. We're going to hit OK, and it's going to draw me the graph for me. So, find the equation of the line in terms of C and N. So, going back to our graphing table, I now have the equation 10 plus 0.075x as my equation. So let me write that in here. So my CAS says y equals 10 plus 0.075x. But have I actually answered the question properly? Have I actually answered the question properly? Look at the question, and what does it say? Find the equation of the line in terms of C and N. Is my equation using C and N? No, so I have to make some changes to my original equation. What am I going to do? What am I swapping around? Replace y with c. Yep, that's correct. C equals 10 plus and X for N. Yep, 0.075 N, where N is the number of calls. So, now remember that this 10 is in $10. This is $10. This is cost in dollars, and that is also in dollars as well. $0.075. What is that actually? $0.075. What units would that be more appropriate to express that in? In cents. So what is $0.075 as cents? All right. Don't round it. Don't round it. Round it at the end. Leave the gradient as it currently is. All right. So it's going to be, and it's not going to be 0.08 cents. It is just going to be 7.5 cents. All right. Now, because this is in dollars, we leave it in dollars for the purposes of my equation. However, it will become relevant in a moment. So it says here, use the equation to calculate the cost of making 300 calls in a month. So we are extrapolating from here to predict the total cost. Now, because this is a linear model, it increases linearly. Our extrapolation can be pretty confident because even though extrapolation means we're going outside the range of data we're provided, it's a linear model. It doesn't vary that much. So where is 300 going to be? It's going to be approximately up here somewhere. Because there. And that means it's going to be whatever. I'm making a prediction. It's about $35. But we have to do it mathematically. So what we need to do is we need to substitute in 300 into where N is. Or we can just use our CAS. So I have my equation here on my CAS. I'm going to draw it. And then what I'm going to do is I'm going to go analysis, gsolve, ycal, when X is 300. Ooh, domain. Cool. So I need to increase it to 40. So I need to change my window a little bit so that my CAS can do what it needs to do. Analysis, gsolve, ycal, X is 300. It's going to tell me it is $32.50 down the bottom here.